Hi everyone, welcome to How to Electronics. In one of my earlier videos, I explained about Ultra Wideband Technology and how it works. For that, we used DW3000 ESP32 UWB Module from MakerFabs. The board was used to range detection and measure short distances between the anchor and tag. The second video I uploaded was related to interpositioning system using the same ESP32 UWB module. For that, I used 3 DW1000 based boards and displayed the detected distance on window using the Python script and plane orientation algorithm. Okay, that was all about the DW1000 UWB chip. Today's video is about an upgraded version of the DW1000 chip called as DW3000 chip. The DW3000 has a lot of advantage over the DW1000 chip. The DW3000 is interoperable with the Apple UI chip, which makes it possible to work with an Apple ecosystem. This means you make your own Apple AirTags. In this tutorial, we will go through the board design, specifications and applications. Then we will learn how to use the ESP32 DW3000 board for high accuracy ranging and localization. We will detect the short distance between the boards and then take it outside to measure long distances. One of the boards will act as a sender, also called a tag. The other device, which is the receiver, is called an anchor. This means anchor is stationary and the tag is movable. We will do all the required outdoor testing. We will also find out how capable the board is in detecting longer distances. So let's get started. This video is sponsored by NextPCB and HQ Online. The HQ Online is a one-stop electronic component sourcing platform. HQ Online provides a complete set of electronic component business services. All you need to do is search the electronic component with a part number. As it has a fastest search engine, it will show you the list of all available parts. Add the part to your cart, then place the order. To get started, check the link in the description. Let's have an overview of the DW3000 chip first. The DW3000 chip is a microcontroller chip produced by the company DecaWave. It is used in the development of ultra-wideband wireless technology for location-based services and precision interpositioning. It utilizes time-of-flight measurement to determine the distance between devices, which allows for precise positioning and location tracking. The module has worldwide UWB support through its operation on UWB channel 5, which is 6.5 GHz, and channel 9, which is 8 GHz. The DW3000 chip is interoperable with the Apple UI chip. The ESP32 UWB Ultra Wideband board from MakerFabs consists of DecaWave DW3000 chip and ESP32 Wi-Fi module. The board acts like a continuously scanning radar that precisely locks onto another device called anchor and communicates with it, thus calculating its own location. You can convert this board into Apple AirTag. The top side of the board has ESP32 W rover module embedded with DW3000 module with other passive electronic components. There are two push buttons, one for flash and the other for rest. The board has a micro USB port for uploading the firmware and for serial communication. On the backside of the board, there is CP2102 chip for UART communication. The name of the input-output ports is also assigned on the board. You can use male or female headers and solder on both sides of the board. To use the DW3000 with ESP32 on Arduino IDE, we need a DW3000 library. The DW3000 library offers the functionality to use DecaWave's DW3000 chips module with any microcontroller. The library supports the transmission of messages and timestamp handling for ranging and location sensing applications and implements the different operation modes of DW1000 has to offer. Let's learn how we can use the ESP32 DW3000 UWB board with Arduino IDE and measure the distance between the boards. For this project, you will need pair of boards. One of the boards will act like an anchor and the other like a tag. For the anchor part, we need nothing except a micro USB cable. But for the tag part, we need 0.96 inches 𝗍𝗲𝗃 OLED display and a power bank. The 𝗍𝗲𝗃 OLED will display the distance of the tag from the anchor. The power bank or a battery will provide power to the movable tag. Let's see the code now. The code that we will use to test the ESP32 DW3000 board is taken from the library example. Using this example, we can do the range testing which practically lies between a 10 to 20 meter distance. Before moving to the testing part, we need to understand the antenna delay calibration. I have explained a detail about the antenna delay calibration in UWB Getting Started video. You can follow it, the link is shared in the description. We have two codes, one for the anchor board and the other for the tag board. We have defined the SPI pins for ESP32 boards. We have set the default antenna delay values for 64 MHz PRF is 16385. You can modify it according to your UWB module behavior and ranging accuracy in the following lines for code. This code has been modified for displaying the distance on a 0.96 inches OLED display. To measure the distance between the board, we need to upload an anchor code to the one ESP32 board and the tag code to the other ESP32 board. Once the code is uploaded, we can start testing the application. To test the range and its accuracy, you can mark the distance on the floor or on a table. I marked a 1 meter distance and between it, I marked positions as 30 cm, 50 cm, 75 cm and 100 cm. Now the device is ready for testing. So let's move and check what the OLED displays. At 30 cm, it shows a distance of 28 cm. At 50 cm, it shows a distance of 48 cm. On increasing the distance to 75 cm, it shows a distance of 77 cm. Finally, for 100 meters. Finally, for 100 cm distance, it shows a distance of 107 cm. For the above testing, we can say the distance it measures is almost accurate, but it still requires a distance test of 10 meters or more. So, let's go outdoors and test the distances. Currently, it is the snowy season in Canada and you can see the snow everywhere. Despite, I need to do the testing. I have my two friends with me who will help me test this product even in such cold, snowy weather. One of my friends has tag on his hand and he is powering the ESP32 UWB module using the power bank. The other friend has anchor which is powered by a laptop. When the tag is nearby, the detected distance was almost 2 meters. While moving away, the detected distance was almost 11.77 meters. On moving further to a longer distance, the OLED shows a distance of 23.75 meters. Then it stopped receiving signals. So as far as our test has maximum distance detected was almost 24 meters, which is more than the maximum measuring ability of 20 meters. Overall, we were satisfied with the working and accuracy of the DW3000 UWB module. Hence, we can say you can use the module for high accuracy localization and testing. That is all from the video part today. The complete project details including device information, purchase link, source code and written guide can be followed in the How to Electronics website article. In case you have any other questions, you can comment in the comment section below. Thank you so much for watching. See you in the next video.